Okay, welcome everyone. Thank you for joining us today's Minitab webinar. Today is Minitab 19 Control Chat. I'm Nosrawati and I'm Technical Support Specialist at Visit System. Visit System is an independent local representation for Minitab product and training in Malaysia and Singapore. Okay, before we get started, there are a few housekeeping items to take notes. If you have questions during presentation, please type them into the question box in your control panel. You may send in any time throughout the presentation, but I will address them during Q&A session at the end of webinar. Kindly ensure that you have connected to the audio via your computer speaker. For your information, this webinar will be recorded and therefore it will be set as listen-only mode to avoid interruption to the audio recording. The recording will be accessed anytime later on our website www.business.com or by subscribing to our YouTube channel, Minitab Malaysia and Singapore. Okay, Minitab was developed in 1917, so almost 50 years in the market. Okay, currently we have a Minitab 19. We just released in June this year. Minitab is a software package for statistical analysis for various analysis like quality, reliability engineering, product development, business analytics, and process validation. Currently, we are leading statistical software for quality improvement and statistic education. Minitab able to use for everyone, whether you are statistician or non-statistician. Minitab also provide features guide you to the answer, like we have features like Minitab Assistant. In Minitab Assistant that help you choose the right tool, we simplify dialogues, but some come out with the detailed report to easy interpreting the finding. Okay, so Minitab will be your data analysis partner. Okay, this one is an example what Minitab can do for you. For example, you can go for the descriptive and inferred statistic. You can go for the visualization like Pareto chart to find out the most important reason why you need to do the process improvement. And then we have a product development. Let's say you call for the contour plot, or you can use the design of experiment (DOE), or you can go for the quality control. Let's say you want to know about your capability of your process. Let's say if you want to go for the capability or control check. And then we have also for the reliability improvement. And then we also take a part for multivariate or classification segmentation. Let's say you have data, a lot of variables in your problem, and then you want to group your data set. Okay, and then we also have a business analytic like time series model, and then we have go for the correlation or regression model, and then and many more on the Minitab. Okay, so I think most of you familiar with this DMAIC framework. So we try mapping our tools in Minitab 19 into this framework. So this one is a DMAIC framework. D is for define, M is for measurement, A is for analyzing, I for improvement, and C for control. So for each part in this stage, we have tools inside the part in this stage. But in this webinar, we go for the control chart, which is you can apply for define and measure part, or you can apply control chart for the control stage. Okay. Okay, the user for Minitab not limited to the manufacturing industry only, but Minitab will be used to others industry like services, finance, and academician. So this one is example of our customer of using the Minitab. And then we go for our agenda today. So for the first part, we go for the overview about the control chart itself. We go for the some theory part before we go for the hands-on part. And then as we know, we have two data type, which is a variables, means that refer to measurement data. And then we have attribute data, refer to the counts data. So it will be reflect to the type of a control chart. Then we can go to basic type of control chart, which is a some variables control chart and the some variable attribute control chart. And the last part, we show the features inside the Minitab. We using a system menu for the control chart. Okay, variation is a fact of our life. So most all of us work to tackle this variation. Okay, many methods like statistical process control, SPC or others quality improvement to reduce the amount of variation in the product or process to make sure that it's always consistent with a good quality. Okay, so the major part in the SPC is a control chart. Basically, control chart are graph that plot our process in time order sequence. Control chart is formed by three lines, which is our upper control limit, center line, and then lower control limit. Okay, control chart is to understand the trend over time of variation occurring in your process. Okay. Besides that, we can separate the common causes of variation, okay, from the special causes of variation through the control chart. Okay, in Minitab, we have a blue dot. Color here is a blue dot, means that the measurement in control or inconsistent state, and but in the red here, red point refer to unusual sources of variation. Means that let's say you have a special causes of variation. Okay, control chart are easy to interpret visual analysis of the process stability. Okay. For your information, we have the two sources of variation, which are common causes and we have a special causes variation. Common is a nature or expected variation in your process. Normally, expected variation is area between lower and upper control limit. And then if you face it with the common causes, where your process is expected to perform unless a change occur. And then for the special causes, or sometimes the terminology for the special is we call it explainable causes, is unexpected variation that result from unusual occurrence, unexpected variation region, okay, area beyond the control limit, whether it's upper or lower control limit, or some non-random pattern in this plotting. Okay, this variability should be investigated and to find out more problem inside the special causes of variation. Okay, for example, for the common causes, you estimate 20 minutes to get ready and then 10 minutes to get to work. Instead, you take only 5 minutes extra getting ready because you have to pack your lunch and then 50 additional minutes to get to work because of the traffic jam. So, for example, for the special causes, let's say you are driving to work and you estimate arrive in 10 minutes every day. One day is the took you 20 minutes to arrive at the work because you caught in the traffic from the accident zone or warehouse. Okay, so this one is in control chart we can take out common and special causes of variation. Okay, so when the right time for us that deploy the control chart. So when you want to demonstrate whether your process is stable and consistent over the time, and then you want to verify your process is it stable before you perform a capability analysis. And then you want to assess the effectiveness of your process changing. Maybe you have some improvement before and after, and then you want to communicate the performance of your process during a specific period of the time. Maybe you have, let's say, first quarter, second quarter, third quarter, so you want to compare your performance for each quarter. Okay. So common question in our mind when to choose the suitable control chart, what type control chart we should do for our process. So we need to consider two factors, which is what type of your data first. And then second is how many subgroup you use. But before we go further, what it means by type of the data. So as we know, we have a continuous of, we call it variables, means that you measure the characteristic of the process, let's say the length, the weight, the height. So it's something like measurement. And then if let's say your attribute data means that the count of your data, let's say defective, okay. And then subgroups means that the measurement you do it in how many observations you take under the same condition. Let's say in 8 a.m. So how many observations you take the sample to take the measurement. Let's say you take the 5. So we consider that now your subgroup size is 5. Okay. And then we go for the basic first. Let's say your data is a variables or continuous or measurement data, and then we're looking for the subgroup size. Let's say you just take only one observation for each hour, so you can proceed with the IMR chart. Instead, individual moving range. Or let's say you have observation less than 9, you can proceed with the X bar chart. X bar means that average, R is a range. Range means that maximum minus minimum. And then if let's say your subgroup size more or equal to 9, so you can proceed with the X bar S chart. So X bar is your average, S is your standard deviation. So this one is, let's say your data is measurement. So let's say your data is count data, or we call it attribute data. So we have a two portion, whether it's a defective or defect per unit. It means that defective only one defect in each observation. So let's say your subgroup is a constant. So every 100, every time you take it, the sample 100, and then you check it, is it defect or not defect. Okay, so you can go for the P chart or NP chart. So based on the, if let's say constant, so go for the NP chart. Let's say is varying, let's say the first time 100, second time maybe 200, based on your demand. Okay, so you can go for the P chart. Or you have a defect per unit, so means that you can go for the C chart, or you can go for the U chart. So let's say you have a C chart for the constant, and then you chart it for the varying of your subgroup size. Okay, so this one is, we call it the basic control chart. But in Minitab, it's not limited to this type of control chart also. We have, let's say, advanced control chart, we call it, let's say, for the multivariate control chart. Okay, and then multivariate, let's say you go for the T2 generalized variation, which is you have your continuous data, variables data, measurement data, you collect from the 2 or more collected variables, okay, at the same time. And then you have a time weighted control chart. Let's say you have Q sum or moving average, or EWMA, or you have a sum amount of the time or the number of unity, so you can go for the G and T. But today webinar we have a limited time to do, just we focus for the variables control chart and attribute control chart. This is for the variables. I just proceed with the S bar chart, and then for the attribute will be for the NP chart only. So if let's say you want to learn more about the others control chart, so you can sign up our training schedule to our website www.business.com. Okay. So before we go for the hands-on session, okay, we need to know this portion. Okay, this portion is testing part to evaluate whether your process in control or out of control. So sometimes we just proceed with the, let's say, have one single data set outside from the upper or lower limit. So we consider that our process is out of control. But sometimes we need to look to our patterns in the control chart. So for let's say we have a 6 point in a row or increase or decrease, we consider, and then we have a 9 point in one row in the same side of the center line. So also we consider the process is not control, and then we have 40 point in a row alternate up and down, or we have a time or 3 point more than 2 standard deviation, okay, or we have 50 point in row within one sigma, or we have 4 out of 5 point more than 1 sigma from the center line, and we have 8 point in a row more than 1 point. So this one is, we have 8 type of the testing for the special causes if you using Minitab. Okay, but for default one, just we proceed with the 1 point more than 2 standard deviation, okay, from the center line. Okay. So before we go for this case study, I will open the Minitab. Okay, so we go for the Minitab first. As I mentioned, we now have the new version, Minitab 19. So the interface is a lot of changing from the previous version. So here we have a navigator. Here we call it output pane, and here is our worksheet. Okay, so if let's say you want to go for the analysis part, you go for the start, go for the control chart. So in this control chart menu, we have a lot of type of control chart, which is variables for subgroup, which is X bar R, S bar S, IMR, okay, or for the variable chart for individual, let's say you go for the IMR or ZMR, okay, or you want to do individual control chart. We have attribute chart, we have P chart, NP chart, we have U chart, we have C chart. And then for the time weight chart, we have moving average. For the multivariate chart, we have generalized variation, multivariate EWME, or we can go for the rare chart. So this portion, okay, we learn today only cover for variables control chart for S bar R, and then we have an attribute NP chart. Okay. So if let's say you want to more know about the enhanced for new version, you can go or learn through our website www.business.com, or you can subscribe our YouTube channel for the past webinar. Okay, but today we just focus only for the control chart portion. Okay, we go back to this case study. Okay, one company used the plastic pellet to manufacture outer cases for computer monitor. They want to evaluate whether the colors of the cases is consistent over the time. So quality inspection randomly select 5 cases every 4 hours over an 8-day period. The color of each case in using the L value L is unit for the scale, so we're using for the color and the MPG. Okay, so means that now the subgroup size is 5 because they take the 5 sample for every 4 hours. Okay, so I think later we go directly to that data set. Okay, this is one, so I go for this one. So in the new version, you can manipulate here just only for the data set. So means that every time, every 4 hours, they take it 5 observation. So after that, after 4 hours, they take it another 5 observations. So means that now your data set is have a subgroup equal to 5. Means that based on this one, the suitable control chart, which is X bar R chart. Means that X bar is average, R is a range. So I go back to this one. Okay, so where you want to get the X bar R chart. Okay, so go for the stat, go for the control chart, go for the subgroup, you choose X bar R chart. Okay, X bar R chart. In the display dialog box, Minitab will ask you, is it your observation for a chart are in one column, which is here, now in one column only, or you have an observation in one row of each column, instead like this one. Okay, we have to weigh. Okay, so this one. So whether this one is we call it observation in one column only, okay, or observation for subgroup in one row of each column. Okay, so we have to weigh. So basically, if let's say you go for the one column one variables, so means that you go here. Okay, so Minitab will ask you how you key in your data. Okay, so different key in your data style with different dialog box will appear here. Okay, so for example, here is for a chart in one column only. So you go here and then you will click if the reading, and then subgroup size, whether you can select in your this one or you can type in. So for this case, we have 5 subgroup, and then click OK. Okay, so now you get your control chart for the X bar, R chart. Okay, I will do, go back to the stat, control chart, subgroup, X bar, R chart. You choose reading, you choose subgroup, and then you click OK. Okay, so you get the X bar. Okay, you get the control chart. Okay, so sometimes our customer always ask how the Minitab calculate for this portion, Okay, how? So we go back to this one. Okay, so for example here, let's say we go for the first sample here. So how they get? So Minitab, they provide the average for each subgroup. So means that they all together and then get the average for the first sample here. Okay, so this one is for the X bar, and then they get all the X bar. That one is in this line. We call it X bar bar. Means that average for each sample here. And then here is the R chart. So how they get the R, the first R here. So from here, okay, we find the maximum number from this for subgroup 1 minus minimum number in subgroup 1. So you get the first R here. And then they get the average for the R bar here. So this one is how they calculate for each sample here. Okay, so I go back to this control chart. Okay, so we get this one control chart. Okay, in Minitab, we have a color code here. So means that in the blue dot here, means that the process in control. Let's say this one is a red color, means that your process is out of control. But what is mean by one? One means that test 1 is refer for 1 point more than 3 standard deviation from each line. So the sample fail at 0.7, okay, 0.7, 0.11, 15, and so on. So they mention what is the test 1. So means that 1 point more than 3 standard deviation. Just this one is I just proceed with the default setting. Let's say you want to checking all the 8 tests for the control check. So go back to this dialog box and then you go for the S bar option. Okay, you choose the test here. Okay, so let's say it's the default one, only one. Okay, so perform selected test for the special cases, or you want to go for the perform all the tests. So means that now you want to perform all the tests. Click OK, and then you click OK. Okay, so now you get 2 here. This one is the first one. Okay, the first one just only proceed with the default setting. This one is you proceed with all the testing for the control check. So means that you have a test 5. Test 5 means that 2 out of 3 points more than standard deviation. And then here is test 6 means that 4 out of 5 more than 1 standard deviation. So from each you can take the action why did happen. So you can further investigate based on this result. Okay, so depends on you. If you want to proceed only one default setting, so you just only get this kind of the result. If let's say you go follow all the rules, okay, you can get more information from there. Okay, let's say your process is out of control. Okay, so we go back to this one. Okay, so based on this one, the process is out of control. Okay, some features you can do it in this control chart. Let's say here you doesn't want because now in this worksheet you have a variable set time, so you can change it this kind of the sample number with the date time. Okay, so go back to this one, go back to scale, and then you choose the same here for this one, and then you choose the date and time, click OK, and then click OK. Okay, so now you get this changing of your x-axis, or some trick you can do it. Let's say here from here, but this one is just only for default setting. So you go for this reading, so variables, your measurement, right click, okay, column property, column formatting. Okay, you go for the Pareto, or you go for the statistical, or you go for the out of control. Okay, and then they ask how many subgroup, so you just proceed 5 and then click OK. So they appear this one. So means that this one is out of control. But this kind of the test only for the first testing is out of control limit only. So they not go through all this testing. Sorry, they not go through all this testing. Go back to this one. Just trick. So they not go through all this testing, just only with the default setting only, the first testing. Okay, means that out of control. Okay, you just want to get the faster result. Okay, so this one is some trick. And then for your information, let's say you already have this kind of the control chart, so you want to omit this of the testing from your process. Instead, you already tackle this kind of the portion. So you want to do the new control chart without this data set. So you can go back to this one, okay, and go for the S bar option, and then go to this estimate. Okay, so you can omit. Let's say here we go omit sample 7. Okay, sample 11. Okay, then okay, go to this one, back this one. Okay, so okay. So this one, maybe you don't want this one, just only proceed the selected default setting. Click OK, click OK. and then you get this one. So now they mention subgroup omitted from the calculation, sample 7, sample 11. So the new UCL you can get after you omit this kind of the sample here. Okay, so means that after you do it the improvement, okay, you want to get the new control limit. Okay, and then also maybe sometime you want to do the, we call it some features like stages. You want to compare before and after. For example, for this case, I just have the vendor here. We have two vendors, A and B. So go here, for example here. A to Z. So I just proceed with the, let's say for vendor A, we can go for the before, and the vendor B, we just assume that this one is the after. So we can go back to the control chart, subgroup, X bar chart, reading, this one X bar chart, and then you can choose the stages here. So define the stages, we go for the vendor. So for let's say click hit OK, and then click OK. Okay, so this one is the features you can using in the Minitab. So you can get this one. So let's say you want to all this control limit for each control limit. So appear here, go back to this one. Sorry, that this one display. So you display here. So click OK, click OK. Okay, so you can get the control limit for each stages. So this features applicable if let's say you want to compare for before and after, you have customer A, customer B, or vendor A, vendor B, so you want to compare the process for each process. So this one is the features. Or sometime you have your own historical data set, means that you all have already have your mean or you already have your standard deviation, so you just want to proceed your control chart based on your value. So you go back to this one. Okay, control chart again, subgroup, sorry. Okay, control chart, subgroup, X bar, R chart, and then go for the X bar chart, and then you can insert your own parameter. For this case, I choose with the mean, with the proceed with the 40. The standard deviation is 0.96. Okay, click OK, and then click OK. Okay, so they calculate for you. Okay, the new control limit with the historical mean and historical standard deviation. Okay, so this one is the trick, how features in this software for your control chart, enhance your control chart. Okay, and then I think this one already here. Okay, so we proceed for another case study here. Okay, for the attribute control chart. Okay, so quality engineer assess whether the process used to manufacture light bulbs in control. The engineer tests 500 light bulbs each hour for the 3-8 hour shift, and they record the number of bulbs that did not light, means that defective. So we're using the defective light bulb. So we go direct to that data set for this one. Okay, go back to this one. So we have this. Okay. Okay, so means that every time they collect 500, and then we have a 5 defect for in subgroup 101, and then we have 8 defective in subgroup 102. This one is the number size of subgroup. This one is the ID subgroup only. So the number of subgroup size is 500. So we go back to this pair of the control chart. What is the best you can using? So So we have attribute data, we have defective, and then our subgroup is constant, is 500. So we proceed with the P, or we can proceed with the NP check. So go back to this case study again. So where is your control P check or NP check? So go to stat, go to control check again, attribute check. We choose NP check. Okay, I will do go to stat, control check, attribute, go for the NP check. And then in this dialog box, they ask you what is your variable, is our defective subgroup size. We have constant 500. And then you click OK. Okay, all we do, go to stat, control chart, attribute, you choose NP chart. You choose defective, you type your subgroup size, and then you click OK, and then you get the NP chart. Okay, so based on this control chart, they have 1 point outside from the 3 standard deviation. So this we consider the process is out of control. Okay, so the same step, maybe you want to enhance with the features. If let's say you have more variables, you want to compare by the shift 1, shift 2, so you can go for the stages. If let's say you already have your own historical mean, so you can proceed with your own control limit. Okay, and then I think we can proceed with our customer is like for this kind of the features. Let's say here, co-assistant. Assistant is okay. So assistant is you can pick appropriate statistical tools. They give it you step-by-step guidance, and then they want to assure you can success. You can run analysis quickly and easily. The dialog box is more simplified, and then you can interpret your result with confidence because they provide you summary report. We provide you variation report, and then they provide you the report card, and then you can share your finding with the one to me. So I will show how assistant will guide you. Okay, so we go for the first case study. Okay, as for the measurement data set. Okay, so where go for the assistant. Okay, go for the control chart. Okay, and then they give it you this kind. What is the continuous? You can click here. Is what is continuous, and they provide you for more understanding. Go for the example, and then what is the attribute? So they can guide you, and then what is the subgroup? If let's say you cannot remember what is the subgroup, so go for the subgroup. So you choose the subgroup. Okay, and then for this example, we have subgroup 5, so you can proceed with the X bar check. Okay, so this dialog box is more simplified rather than using the start menu button. So in one subgroup, here is our rating. So it's constant 5. So this one they will estimate from the value. So if let's say you have your own variable, so you can get type your own historical variables for mean and distribution, and then you click OK. Okay, so now they give you the summary report. They will you is the process is the means demo. Okay, and then they provide you the comment here, and then your X bar chart here, and then they have a stability report. Okay, they provide you the trend. Okay, so you need to look our pattern, the trend in your control chart, and then they mention the chart is outside the control limit, and then they provide you the report card. Okay, so this one is differences between using the menu button or you using the assistant. Okay, So this one is system and this one. So both of these graph, you can easily share, whether you want to share to PowerPoint or you want to share to the words. So just right click, okay, send to PowerPoint or send to Word. Let's say send to words. Okay. So now you get this kind of the report. Okay. So you can go over here. I go back for this one. Okay, so we have a two-way, whether you're using start menu button, okay, start, control chart, as if let's say go proceed with the S bar chart, variables chart for the S bar chart, or you can go for the start, control chart, individual INR chart, or you can proceed with the attribute chart of the chart, U chart or C chart. Or you have a assistant menu. Go to assistant, go to control chart. And then they guide you what is the data type, what is the subcode size, and then you proceed with the SPR chart. So we have a two-way, whether using the start menu button or you can using the assistant menu button. Okay. Then this one. Okay. So for the summary here, okay. Stable and in control process is prerequisite for further analysis such as capability or predictive analysis. If your process is stable, you can predict future performance and improve its capability. However, a stable process does not necessarily mean that it's capable. So for the control chart is a crucial tools before you go for further analysis. Let's say you want to go for the capability or predictive analysis. Okay. So any question? Any question? Any question? If you have question, you need to type your question in the question box or chat box. Any question? Also, you have any question, I will just recap again what we learned today webinar. For the control chart, I will just to stress on this portion only. Okay, for this portion only. Okay. So I will recap again the type of control chart before you decide which one is the best control chart for you. So you need to know what is the data type, whether the variables or attribute chart. So in variables, you need to consider other subgroup size, we call it. So let's say your subgroup size is only one of the version for each time, so you can go for the individual or moving range chart. Or let's say you go for the n more than one, less than 9, so you can go for the S bar chart. S bar means average, R is your range. And then for the n, more than 9, you can go for the X bar as check. X bar means average, S is the standard deviation. And then go for the attribute when your data is count data, which is defective. So you hand your constant, your n is constant, you can proceed with the P or NP chat, or you can go for the variant, you can go for P chat. So if let's say your data is a defect, you can go for the C chat or U chat. If let's say for the variant, you can go for the U chat. Okay, and then this one is not that limited for the this basic control chart. We also have to multivariate advanced control chart, like multivariate control chart. We have time weight control chart, and then we have rate even control chart. But if let's say you want to learn more about this, you need to sign up our training. Okay, if you want interest, you need go for the our website www.disease.com. Okay. So if doesn't have any question, so if let's say you want to try or buy Minitab19, you can go for the our website www.disease.com or www.minitab.com, or you can contact us or email us to sales@disease.com or minitab@disease.com. If let's say you want to learn more, maybe we have some trick and tips for using Minitab, not limited for the control check, or you want to know about our event, the next event, so you can follow us to our media source. Let's say for the Facebook, Minitab, Malaysia and Singapore, offer link Minitab in Singapore. Okay. So thanks your time, and I will wish in Happy New Year to all of you. Thanks.